All right, finance solver. This is where we get into the guts of recursion and financial modeling. We're going to be moving away from using these recurrence relations and looking at how to use the finance solver function on your CAS. So a number of questions in the finance module are actually solved using this CAS component. Sometimes it's referred to as TVM, time, value, and money, or finance solver. So we use this particular application to solve situations where there is a regular payment being made, whether it's a repayment or a deposit. So some of those situations involve reducing balance loans, which we've already looked at. There's also annuities and annuity investments. And then interest-only loans and perpetuities are a simpler version as well. So that's what we're going to be covering in the rest of Chapter 9. Now, anytime you have a regular repayment, you're going to be using your finance solver to solve those questions unless it has asked for a recurrence relation. And there are some particular rules around how to use your finance solver. The main rules is that we need to be aware of the fact that money has direction. Money can either be positive or negative. Money that comes to you makes you happy, so it's going to be positive. Money that you have to give to the bank makes you sad, so it's going to be negative. Yeah, okay. The positive and the negative tells us the direction that the money is flowing in. Now, when you open up Finance Solver on your CAS, so it's Menu, Finance, and then Finance Solver, it opens up this particular page, and there's a whole bunch of boxes that you've got to be able to fill in. Right, so N represents the total number of payments that you're making over the life of the loan. I represents the interest rate per annum, so it's not adjusted for compounding periods. PV represents the present value or the start value of the loan or the investment or whatever. PMT represents the payment. FV is the future value that you're intending it to be. And then PPY and CPY refer to the payments per year and the compound periods per year. And these should usually be exactly the same. If your loan is compounding monthly, then you should make monthly payments. All right, so this is where we relate to our T value from our compound formula rule. Tells us how many times something is compounding. Also tells us how many payments there will be per year. All right, so let's have a look at an example for these reducing balance loans. Now, this is where this particular sheet's going to come back in handy. When you get a question, the first thing you're going to ask yourself is there a regular repayment? And if there is, that tells us that we have a reducing balance loan, an annuity, or an annuity investment. So how do you then tell the difference between those three things? So if we go down here, you'll notice that for a reducing balance loan, we actually have a positive payment and a positive present value and a negative payment. Okay. So the wording, and I think I've said before a couple of times that money or words have directions. Words are either going to be positive or negative. So we're looking at those words to determine whether or not you've got a reducing balance loan or not. Now, you're pretty lucky. In most cases, an example will actually tell you if it's a reducing balance loan. But in a reducing balance loan, the bank lends us money. So that means that our present value is going to be positive because we get that money, that makes us happy. We then pay off the loan in regular amounts. We have to give the bank that money, which makes the payment negative. And then eventually you shouldn't owe the bank any money at all. So our future value should either be zero or it's going to be negative because we still need to give the bank money. So let's have a look at this particular example. If Aaron borrows is a positive word. Again, I'm going to go back to this page. Underneath this list, you've got a lot of keywords. And we can see there that borrow is a positive word, because when you borrow money, you get the money, and that makes you happy. So if I'm borrowing 10,000, that's going to be a positive word, which makes my present value positive. And if my present value is positive, that makes it a reducing balance loan. We can also see here it's compounding monthly. She's making monthly repayments. Okay, and we're interested in how much she should repay. So I'm going to start off to solve this question by writing out all of my variables here that I need to fill in. So I need N, I need the interest rate, I need the present value, I need the payment, I need the future value, and then I need the number of compounding periods per year, which would be the same as the periods per year is the same, payments per year is the same as the compound periods per year. So this is the first thing I'm going to write down when solving this kind of question. N is the total number of payments that she's going to make. Now, if I'm making monthly repayments over 5 years, that means that I'm going to make a total of 60 repayments. My interest rate is 8% per annum. I'm going to borrow $10,000. Do I know how much the payment is? No, I do not. So that's going to be left unknown for the time being. Now, if I'm paying off the loan, how much do I owe on it by the end? Well, I've paid it off, so hopefully I should owe nothing. And if it's compounding monthly, then the number of payments that I will make per year is 12. So I now need to solve for my payment. Now, when I solve for this, I'm expecting my payment to be a negative amount, because I'm having to give that to the bank in order to pay that money off. So in my calculator now, that's 60, 8%. I borrowed $10,000, and that's a positive amount because I get that money. I don't know the payment. Future value, I'm going to pay all that off. That's going to be 0. Payments per year is 12, and you'll see that the number of compound periods also remains at 12, or it will change automatically. I'm then going to put my cursor in the tab or in the box that I'm trying to solve for, and you'll see it says press enter to calculate payment. So I'm going to press enter. Lo and behold, I do get a negative value, negative 202.76. So negative 202.76. Therefore, so my payment should be $202.76. Remember, our value is negative because that's money I have to give to the bank. Giving money makes us sad. All right, now in any reducing balance loan question, you could solve for any one of these variables. So you might be solved for N, you might solve for R, you might solve for the PV, you might solve for the payment, etc. It just depends on the information that you've been given. And if you're not sure which one you're solving for, write them all out and look at which one is left empty. All right, so here we have, and again, we see that we're borrowing money. That's a positive value, so it's a positive PV. And if I look on here, the only one that has a positive PV is a reducing balance loan. So it has to be a reducing balance loan if I have a positive present value, a positive amount that I initially borrow. All right, 7.5% compounding monthly. If the loan is repaid after 15 years, so N, that's going to be 15 by 12. You don't even have to do the math, you just have to type it into your calculator, it'll work it out itself. Interest rate is 7.5, present value 140,000. Payment, I don't know. If I've repaid the entire loan is repaid, that means that I owe nothing on it. And the payments per year and the compound periods per year is monthly. So I'm going to solve for my payment. Go back into my calculator. So that's 12 times by 15. Yep, see, it works out for me. 7.5% interest, 140,000. Don't know what that is. Future value is being paid off. Yep, 12. Alright, so I'm going to put my cursor in the payment section and press enter. The payment should be $1,297.82. Remember, for money should always be decimal places. So negative 1297.82. Alright, the total amount repaid on the loan. Alright, so there's not a hard and fast rule for this one. But you've got to think, alright, the total amount paid is how much you actually end up giving the bank. Yeah, I've borrowed 140,000, but that's not what I've actually ended up paying out. So my total amount is going to equal the number of payments times by my payment amount. So in that case, if we use our values from above, it's N times by PMT. So I made 180 payments of $1,297.82 to pay off this loan, which means the total amount paid back, I'm just going to have to get out of this for a moment, 180 times by 1297.82. Right, so I've paid back 233,608. Now I bet that's not, there we go, 0.6. So 233,607.6. Oh, for fuck's sake, stop doing that. 60 because it's money. So for a loan that only cost me 140,000, it's cost me $233,607.60 to pay it off. So the amount of interest is always the difference between the initial amount and the final amount that you pay. So the final amount that I paid for this, or the final amount that whoever it was in this example paid, was $233,607.60 on a loan that was only $140,000. So interest is our extra amount of money that we've paid. So I've paid an extra $93,607 $1,000,000.60. That's a lot of extra money that you end up paying back. But that's how loans work. All right, another example. All right, Adele borrows 30,000. Borrows is a positive present value. 8.5%. Now, adjusted monthly is the same as compounded monthly. It's just different bank terminology. She's going to make payments of $650 per month. And we want to know how much is still owing after 2 years. So let's go through our process. And how many payments has she made after 2 years? Well, she's made 2 years of monthly repayments. Our interest rate is 8.5%. She borrows 30,000, and that makes her happy, so it's a positive value. Now, payment has to be a negative value, negative 650, because repayments are a negative value. And in a reducing balance loan, our payment must always be negative. So that's probably one of the key problems here, is that students will forget to put the negative into their calculations. Now, she hasn't actually paid the loan off. We're actually asked how much she's still owing. So we at this stage don't know how much she's owing. So this is where, in this case, your future value is either going to be 0 or negative, because when it's negative, we're actually going to be solving for it, because we still have to give money back to the bank. So if your future value is not 0, if the loan hasn't been repaid, then you're usually going to be solving for that future value. All right, payments per year. It's being adjusted monthly, so that's compounded monthly. So I'm now going to solve for my future value. So that was 2 years of monthly payments. That was 24 payments. At an interest rate of 8.5. And she borrowed 30,000. That's going to be a positive value. I have to enter in a negative payment of $650. Future value, I don't know yet. So these all then stay empty. Payments per year is 12, compound periods per year is 12. Yep, all good. So I'm going to solve for my future value. Alright, so after 2 years, I have a negative value. That means I still need to give the bank that much money. So this is negative 18,598. $598.56. So she still owes $18,598.56. All right. How long will it take to repay this loan? All right. Well, how long? Well, we don't know how long, so I can't calculate the number of payments because I don't know how long it's lasted for. But my interest rate is still 8.5. I know that I've borrowed 30,000. I know that my payment is negative 650. If I have repaid the loan, that makes my future value 0 if it's been repaid. And compound periods per year, payments per year is going to stay at 12. Alright, so repay always means that our future value is 0. So we're going to solve for n in this case. Now this is going to tell us the total number of payments that we've made. So I want this to be 0 now. And I don't know the number of payments. I'm going to solve the number of payments by hitting enter. So that's 56.09. Alright, so I'm just going to show you something here. Do we round that to 56 or do we round that to 57? So let's do 56 payments. How much, does that mean that I've got nothing owing? No. So she still actually owes money. So in this case, we actually need to round this up, because if you round it down to 56 payments and check how much is still owing, there is still money owing. So we need to then round this up to the next. Alright, so we have to round it up to ensure we repay the whole amount. So this is going to take 57, and this is months. Because remember, we were making monthly payments. So 57 months, it's what, 4 years, and what's that? No, 57 divided by 12. Yeah, 4 years and 9 months. However you want to answer it. It might ask you to say it to the nearest month. It might ask you to do years. Right, now there are more notes to go through, but I'm actually going to leave this one here, and we're going to come back and do this bit when we're back at school, because I think you guys need to just work on doing basic ones before we get into some of these ones where the terms of the loan change. So we're just going to leave that for the moment. Alright, so that is 9C, using your finance solver, and we're going to be using this, like I said, for the remainder of this chapter to solve any particular question that has a payment, which is why the very first question on this little solving thing is there a regular repayment? Because that's what's going to tell us whether or not it's a chapter 8 or a chapter 9 question.